All right, so I've gotten some requests that we go over stoichiometry some more, that people are starting to worry about that for the exam, and they shouldn't. I don't remember it being a bunch of problems, but it is something you should know when you leave this class. So I'm going to make this video that's basically going to try to go back to stoichiometry and remind you the things you need to realize are, and I think you have this down pretty good, grams to moles. If you're looking at grams to moles, then you get that from the periodic table. If you have moles to moles, you get that from the balanced equation. And if you got moles to grams, you get that from the periodic table. So every question is going to have one of two starting points. It's either going to ask grams or moles at the beginning, and it's either going to end with what are the moles or what are the grams. So you're either going to get on this highway. This is a Quigley explanation. I think it works really well. So if the question starts with grams, you're going to get on the highway at grams. You always have to go moles to moles. The whole reason we taught you balancing equations and whatnot is that you must go through this blue box. And then you either get off if that's it and you just needed moles. But if you need grams again, you go one more and again use the periodic table to go back to grams. So let's take a look at this first. So there's the must use. Let's take a look at the first question here. So propane reacts with oxygen, form carbon dioxide and water. How many moles of water will form when 6.7 moles of oxygen react with excess propane? So the excess, remember, this is cover our butts about the we're covering ourselves for limiting reagent. Okay, so we start with moles. Come on, pen. Nope, pen doesn't want to work. So we're going to use this pen. All right, we start with moles. You see that? So if we go back to this, we're getting on the highway right here. We're getting on at moles. We didn't have grams to start. We started with moles. Now let's see where we're getting off. And we're going to how many moles of water? Moles of water. So we're getting off this highway here. So we're just going through the balanced equation. We're not going to need the periodic table in any way here because we're starting at moles and we're done with moles. So let's start here. So we're given 6.70 moles. So that's the 6.7, and I apologize that this won't look pretty. And we need moles of water. And we need moles of water. And so to do that, we're going to start with, and that was 6.70 moles of oxygen of O2. All right, so we're going to start with the 6.7, and the only relationship we just went over, the highway we're using up is the mole to mole, so we're going to need to go through the balanced equation. So 6.70 moles of oxygen, use that, and we need to get rid of moles of oxygen, and we need to go to moles of water. So moles of oxygen, and we need to go to moles of water, and that relationship being moles to moles comes from the balanced equation. And if we look up there, you will see that the relationship of water to oxygen is there's 4 moles of oxygen for every 4 moles of water for every 5 moles of oxygen. So the 5, the coefficient stays with the oxygen, and the 4 stays with the water. And that's it. We're done. As we just pointed out, we're going moles to moles. So we just needed the balanced equation. So 6.7 times 4 divided by 5 is our answer. And unfortunately, I didn't bring my calculator. So we're going to just go with, we'll keep that for now, and I'll curse you all later when I'm trying to do this. So 6.7 times 4 divided by 5. And that gives us 5.36 moles of water. So that's what we got, 5.36 moles of water. And that's the answer. So let's move on to the next one. Let's just do that real quick. 5.36. Where's my... Can't see me. There I am. 5.36. 5.36. 3, 6. All right, so that's moles of water. All right, moving on. In this question, we are given, we want to look for moles. We're given grams, right? Here is grams of propane gas. So I did that in green because we're going to need to use the green box this time, but we're going to moles of water. So if we go back to our highway, in this case, we are going to, let's see if I can use my eraser. Nope, I can't. But in this case, we're starting in grams. So we're going to start here. We're going to start right here. And we're getting off at moles. So we're going to get off right here. So we are going to need the periodic table this time. We're going to use the periodic table once, and then we're going to use the balanced equation, which is a must use. And then we're going to get off right there. We're not going to need the periodic table a second time. So let's move on to this problem. So the given is 94.16 grams of propane. So I'll switch back to green. So it's 94.16 grams of propane. And to make that disappear, we need the balanced equation. The periodic table. So we want grams in the bottom, and we want moles in the top, so that we can go mole to mole through the balanced equation. Whenever we use the periodic table, the number of moles is 1. And then we're going to add 3 times 12, which is 36, plus 8, which is 44. So that is 44 grams from the periodic table of propane, C3H8. I should have that here somewhere, C3H8. H8, just so you know. And that does not look like that at all. Maybe I should have done that. All right, so now we have moles of C3H8, and we have to go to moles of water, right? Is that what it says, moles of water? So we're at moles of C3H8, and the way we get to moles of water is the balanced equation. So balanced equation is where we get the moles to moles from, so I'm going to do that in blue. And we have moles of C3H8 in the bottom, and we have moles of water on the top. And maybe I'll get one of those fancy pens where this actually works. I tried to find one. And we want moles of water on the top. And we get that from the balanced equation, right? Mole to mole we get from the balanced equation. So moles of C3H8 is 1, understood. Moles of water is 4. So that's a 4 next to the water, and it's a 1 next to this. So it's 94 divided by 44, and then times 4. So we're going to escape this. We're going to use our calculator again. Escape this. I'm going to keep that under my... So 94.16 divided by 44, which is the molecular weight of propane, and we're going to multiply that times 4, which is the weight of water, and it's 8.56 is our answer. So 8.56 moles of water is the answer, and we'll do that, 8.56. 8.56 moles water. All right, so, and that's how you do these, and we're doing good, it seems. So let's look here. Another problem, same balanced equation, just for simplicity. I'm doing that, and maybe you're already figuring things out because I'm using green. What are we given? We want how many moles of carbon dioxide are produced when 440 grams of propane reacts with 320 grams of oxygen. So this is actually a limiting reagent problem, and I think more than we actually cover on the exam. So I will very quickly look at this and say that the limiting reagent is going to be oxygen, I believe. That's what I believe. So, and that's just because looking at this, there'll be 10 moles of this and 10 moles of that. And since I need 5 of these for every one of those, that means I'll use up the oxygen faster than the propane. That was a real quick lesson on that, but we're just going to go 320 grams. So we're given 320 grams, and we're going to moles of carbon dioxide. And let's go to grams. Let's pretend this says grams, just so that you get the one last, because we've already done moles a few times now. So going to grams of carbon dioxide. All right, so in our highway here, if I may, let me keep all that, and then let me get rid of this stuff, and we'll get rid of those. All right, so on our highway, we are here. So we are starting at grams. We were given grams of oxygen and grams of propane. So we're starting here. We have to go through moles of stuff. I don't know how to do this now. So we must use our moles, and then we're going to go to grams of, I don't know what I'm doing, kids, as you can see. All right, then we got to go all the way to grams of product. And if you see my stuff rolling around, let me know. I do not see there it is. All right, so we're going all the way over here. All right, so we're going through the periodic table, through the balanced equation, through the periodic table again. So let's do that. All right, so we have 400, what I say we're going to use the oxygen. So we're going to go 320 grams of oxygen, 320 grams of O2. And then the first step is to go from grams to moles. And to go from grams to moles on our highway or anything, you should know this, is periodic table. And whenever you use the periodic table, it's 1 mole, and the grams is oxygen. Each one is 16. There's 2 of them, so that's a total of 32. So it's 32 grams of oxygen in 1 mole of oxygen. Now, on our highway, the next place we're going is the mole to mole. And the mole to mole is through the balanced equation. And we want moles of oxygen in the bottom, and we want moles of carbon dioxide on the top, because that's where we're headed. So we got moles of oxygen on the bottom, we got moles of CO2 on the top, and we get that from the balanced equation. And we look here at our coefficients, and we have a 3 associated with carbon dioxide. We have a 5 associated with the oxygen. So it takes 3 of these for every 5 of those. And then we need to do one more. And again, if we look back at our highway, we've done grams to moles, wherever my pen is. Where's my pen? There's my pen. So we've done this one. We've done this one. We're now on this one. So we're going to need that periodic table again. And we're going from, let me turn to green since we're on the periodic table. Maybe that'll help you. We got to go from moles of carbon dioxide to grams of carbon dioxide. And we're going to use the periodic table. That's CO2. So whenever we use the periodic table, the number of moles is 1. And then gram-wise, carbon is 12, and 2 times 16 is 32. So 32 plus 12 is 44 grams. So we get that from the periodic table, 44 grams of carbon dioxide per mole. So now we multiply the tops and divide by the bottoms, and we get an answer. Let's keep that again, and I'll clean it up later. So multiplying wise, we got 320 divided by 32 equals that, times 3 for the 3 moles of carbon dioxide, divided by 5 for the moles of oxygen, and then times 44. Times 44. And so it'll be 264 grams of carbon dioxide. 264 grams. Am I in green? I am not. Now I'm in green. So 264 grams is the answer. All right, so I hope that helped. And again, we can talk about it more tomorrow. But thank you for the questions. Please keep sending questions in on email or through the other thing that we have, and I'll be good. All right.